Hello and welcome to Tech Lessons with Alvin. Now today promises to be an interesting one. I really hope you enjoy it. It was fun researching this because I got to learn a lot about the address resolution protocol, and I'm here to share with you a more compressed version of what I've been able to gather. And I hope that despite it being compressed, it won't be, how will I put this best? It won't be too verbose. There will actually be some sense in it and some value that you can derive from this brief presentation. So I've packed it as best as I could, yet tried to make it as trim and slim as possible. So the full name for ARP is Address Resolution Protocol. Now this is based, I missed the B there, but this is based on the network layer of the TCP IP model. We previously discussed the OSI model. The TCP IP model is the modern version. It's more widely used, right? And that's the fourth layer. So we'll start from here, check out a few protocols, then we move to layer 3, 2, and then 1. And so, yeah, that's what we are looking at right now, Address Resolution Protocol. What is it? It is a procedure for mapping a dynamic IP address to a permanent physical machine address in a local area network. The physical machine address is also known as a media access control address or MAC address, right? Now, we have static IP addresses and dynamic IP addresses. Static means the IP address doesn't change. Dynamic means anytime you connect, you get a new IP address. It's constantly changing. So the address resolution, the word resolution here tells you it is resolving. It's resolving what to what. It's resolving IP addresses to MAC addresses. Now, what else can we learn? Well, the address resolution protocol is one of the most important protocols of the network layer in the OSI model and the TCP IP model, which helps in finding the MAC address given the IP address of the system. Now let me pause here. So it already has the IP address. So we'll dig deeper with an example in following slides. But it already has an IP address, but it's looking for a MAC address. There's the resolving. Now we need to resolve something, right? So that is the main duty of the ARP. It is to convert the 32-bit IP address to 42-bit MAC address. So what you are looking at here, I know most of you are experts and can tell from that capital C that, oh my, this is a command prompt. Yeah, this is the command prompt window. You are right. You're 100% right. But what is this showing us? You can also tell the experts that it is when you type in that let me bring the mouse. This thing, the ARP space -A, is when you type this in that you get this. Now what's this? What is that? Now that is called the ARP table. It's called the ARP table or the ARP cache. Now your browser has a cache, right? It saves the IP addresses of the websites you visit, and it enables it to load the pages faster. When you type in Google, it already has it in its cache, so it picks it and displays the web page quickly for you, right? Now that is it. It's more like an index, right? It keeps or stores IP addresses matched to already gathered physical addresses or MAC addresses, and they all correspond. This corresponds to this, this corresponds to this, this corresponds to this, and it gives you the type as well. You can tell the first three are dynamic, meaning if I connect again and try to access this, maybe if this represents google.com, right? If I try to access it, it won't always give me the same website. Now let's say it is 192.168.4.4, right? .4.4. That's my website, alvin.com. But then because it's dynamic, if I log on again and type alvin.com, it may route me again to a different website, maybe 192.168.10.20. That's what makes it dynamic. It doesn't always lead you. So maybe these pirate base, and then all those other websites we use for downloading movies and games, most of them have dynamic addresses, right? Excellent. Sorry for the noise. Yeah, let's move on. So here, what are we looking at? No, what is this? What are we looking at? So in the network environment, right, of course, all the machines communicate with each other. They all pass through the switch, if they are all connected through a switch. And if you have different networks communicating with each other, you may have to make use of a router. That's also, if you're accessing the internet, you may have to make use of an internet router. That router is called your gateway, right? Excellent. So in that network, let's think of an office environment, right? You were recently employed in this new office environment. You sit behind your desktop for the first time. You switch it on, you change the password, you put in your new password. You have in a way branded it. It is your machine, right? But now you want to communicate with someone in the marketing department. You need to send some files to that person. What do you do now? You may go to your mail, type in or attach whatever file it is you want to send over to that person. But then the ARP comes into play here because it is this machine's first time of communicating with that person, right, over the network. It's the first time. Oh my god, we don't know this person. All we know is the IP address. Now, where is the machine itself, right? So we know where we are going. And that machine's address is called the MAC address, the MAC address. So what you're looking at here is your own MAC address. That is already known. Your IP address, it is already known. No problem. But now you are sending that mail, so to speak. You are sending that information to the person on the team on the same network. Then all you know is his IP address. All your computer knows is his IP address. You don't have that in your mind, right? 192.16.20.204, but you don't know his MAC address. So your machine sends this ARP request message. This is a broadcast message. Every person, every node on the network will receive this request message, but not every node will reply. Only one will reply. That's why it's called a broadcast message. Everyone will get it. And the machine whose IP address tallies with this IP address will reply with the ARP reply message and will add his MAC address in the reply to the source or the sender, which is you sitting behind your machine. These things go, they operate at light speed, so it's not something you have to wait and you get to actually observe with your naked eye. Before you can even snap your finger, all this has happened already, right? So now your sender is the person, right? Don't be confused. It's not you this time. Since someone is replying, since the accountant or the guy in the marketing team, his machine is doing the reply, and he is now the sender, right? So you will notice that his IP address is 192.16.20.204, and here 192.16.20.204 is the sender, and now we have the MAC address. This is what we wanted, and now we have it, right? It also already knows our MAC address since we sent it to him along with the IP address. Now we are set. We can communicate. What happens is, let me go back a bit. It is now saved in the cache in this ARP table. So next time it doesn't need to send out broadcast. It already knows where it is going. It already has the IP address of that computer or that machine belonging to the person you wanted to communicate with. He already has his IP address mapped onto his MAC address, so there is no need to broadcast the ARP, the address resolution protocol, right? Good. Now, an analogy to get this to sink in. You know how much I love analogies. I believe if you have a familiar anchor to tie this thing to, in a way cement your understanding, you will never forget it. It works for me, and I keep doing it because I believe it works for everyone else. So it's just like this. This is, I had to read a bit on it. It's strange. ARP actually ended up with me reading about echolocation. But then this is echolocation, right? We may have heard of it before. Bats communicate because they are blind. This is how they communicate. This is how they communicate with other bats, and this is how they see. They see by means of sound. So they don't crash into objects as you see in the first image, and they are able to find food to eat. Right? Why am I bringing this? What the hell do bats have to do with address resolution protocol? Well, you can liken that sonar wave, those sonar waves that the bat emits, to the broadcast, right? To the ARP request. It goes to every node on the network. The way those waves hit everything in front and even around the bat. So the bat knows where everything is. But if the bat is specifically looking for food to eat, what happens? As you can see, it gets feedback, of course, from the wood saying, oh, okay, this is an obstacle, I need to dodge. But it also gets feedback from the food, right? Which in this case is a moth. So it knows, okay, now that's the moth. That's what I should be looking for. Now, I don't want to make much ado about nothing, right? I believe you already understand the point before I even started talking. So, to simplify matters, the bat sends the broadcast message. The meal, which is the moth, receives it just by being there. It sends a reply to the bat, and the bat now is aware of the position of the moth, and so the bat can now swoop in and eat. So I really hope this very corny analogy made a bit of sense, and I hope these slides as well were able to be of help to you in understanding the ARP protocol. Thank you very, very much, and this has been Tech Lessons with Alvin.